Now, as we start our next page, which I believe is 58, we're going to just get some general impressions of what do a graph like these look like, and what sort of happens to them. Well, here we've done this before. This is your standard parabola where the vertex is at the origin, and it looks like so. Now, when we look at what is inside the parenthesis here, we have an x minus 4. But we said in this position, the value of our x is actually the opposite sign of this, and it shifts it to the right 4 places. So this is what you want to have in your booklets. Now, we also have a graphing calculator online, I have, and again, our first one would be y equals x squared. That's this one, you see part of it here. It's going through the origin. And this will be y equals, and then in parentheses, x minus 4, the quantity squared, just shifts it over to the right 4 units. So our axis of symmetry is here y equals 4, and our axis of symmetry here, if you recall, y equals 0. A vertical line going through the y-axis here, or the x-axis I should say. Yes, so this would be the equation. I should have thought about that a little bit more. It'd be, the line is x equals 0, again a vertical line, and here it's x equals 4, the axis of symmetry. In example 2 now, we see this one is the typical parabola going through the origin. Now notice this is a position of our y-intercept, so it just shifts your graph up 3. And if we wanted to see this in our other form here, there I've got, so you can see the equations that I've plugged in, and then there is the first one there going through the origin, and the other one just going through where 3 is here, halfway between a 2 and a 4. Now in example 3, we're getting the function y is equal to x to the 3rd power. We get this particular shaped graph. Again, it's going through the origin right there. And comparing this graph to this graph, this is 1/3 x to the 3rd. And again, we're wondering what happens here. Well, can you see it's going to shift a little bit more outward here, as we see here. And if we look at this official variation here, we see the green line is the standard y equals x to the 3rd, while this purplish line is 1/3 x to the 3rd. And again, we're looking at what can we pick out from the graph of this, which is your typical parabola opening upwards, to this one now that gets a little more challenging. Well, as we see this, we can actually put it from its standard form into its vertex form. So we see now the vertex of this parabola is at -2, 16, which is right about there. And if x is 0, y would equal 12, so this is our y-intercept right there. So our parabola is going to go down through here, up through there, and this graph then would look like this, compared to this one, keeping in mind that this is your y-intercept. And officially, we look at it in properly made graphs, it looks like this. This here is your origin and vertex of this equation. And when we plot this equation, we get our vertex here as a -2, -16 here. That didn't come out too well. And it's our y-intercept here, right there at -12. Okay. And we just want to compare these graphs of radicals now. We had done this before. The function of f is this. And again, it starts at 0. And it looks like so. Now, what happens when under the radical sign, the radicand is x plus 3? Well, we said generally it shifts it now. Instead of a +3, it goes to a -3. Shifts it to the left. And that's the basic difference. And if we look at our professional graph, that's what you see here. It starts here at 0 for this first one. And then the x plus 3 shifts it over to 3. Okay? And we mentioned the shortcut of something like this is that it's the opposite sign. So there is 0, and there the 3 is there. -3. And notice they have our scale a little funny here, because each unit this is 5 blocks to a -4. So this is actually where -3 is. -2 would be right about there, and -1 would be there. Okay, going on to our next page, we are asked to graph the following, and how does it compare to these functions? Well, let's do this one first. We know this one is just going to be like so here, and then like so here, going through the origin. Well, this one, when it's 3 times this, instead of being this way, it's a little closer in here. So if you put the same on both graphs, we see in the first case, the blue line is your x to the 3rd, and then 3x to the 3rd is inside it. Remember, as we said, this coefficient gets larger. It moves this line in toward the y-axis. Okay, it's nice to see it done so nicely here. Now in example 3, as we look at it, we know that this function would, let me just do a quick sketch over here, would look like so. But then now +8 is our new y-intercept, so we have to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's our same graph going through 8. So this one is easy. Now let's take a look at this one. So as we look at example 3 in more detail, let's develop our lines here. Now we should have picked up a little bit from what we've done so far. If we see something like this, this is going to shift the graph over to the left 2 units. And down, now this is our y-intercept, 6 units. So 1, 2, 3, 4, 5, 6. So this is going to be our point of intersection. And then this will look like something like this here. Again, I didn't draw that too well. Let's take a look at what it would do officially. But before we leave this, again, you see you're moving it over to the left 2 units and then down 6. This is your y-intercept has been shifted because of this value. And it's the typical cubic function. And here we see it beautifully done. Keeping in mind that this is where our -4 is. So up here, this is where our 0 is. So our 2 is right about, let me get a point going here. Our 2 is halfway. And these grid marks they make it nice, but there's 5 grid marks, but it's only 4 units. And then down here, it's between -4 and -8, which is 6, which is right about there. So there's what this graph looks like. Again, you want to be able to pick out what happens to the shape of the graph. Well, if it was just y equals x to the 3rd, then your typical shape of that was this, going through 0. But now we're going through a +4. We're moving it up, and we're broadening it out. So this is 1/4. So this will come out a lot broader here. And looking like so. Here this is a 1, so this is in closer. This is 1/4, so these wings, in a sense, spread out further. Let's see it officially here now. And there it is. Okay, this is a good little program, and of course if you have your graphing calculators, that would work very well too. So in looking at this one, we see it's y equals x to the 3rd power was something that looked like this. I didn't do that too well here. There we go. Still not great. But what's happening here now? Well, we know our y-intercept is raised up to 7. So 1, 2, 3, 4, 6, 7. And then this is a -3. So we're going to shift it over 3. 1, 2, 3 in a positive direction. So our new line here is going to go at this point. And then we have a 4 in there. So instead of being this broad, it's going to be much more narrow. Like so. So up here at 7, but shifted over to the right because of this -3, opposite sign, and because of the 4, it's going to be in closer to your axis of symmetry. And let's see what it looks like officially here. There you go. Pretty. So right there is where 7 is. And then since it's 4, it's in much closer. And then this is about where your +3 is, right there. Okay, well, I think we did a lot of work, and hopefully, I know it took me a long time to do this because I was researching this and developing that, but hopefully this is helpful for you.